I think ISI is special because we can work there on any problem that we want, any problem that is fun and important to society. Our funding sources actually give us money to work on really interesting projects and problems that are important to society and that we couldn't really solve if we were just at a university. It really requires a place like ISI where we can assemble big teams and work on practical problems that require scientific breakthroughs, but also require a commitment to actually work until you get it right and you can solve the problem. That's what makes ISI fun. I grew up in Colombia, in the capital city, Bogotá. And I went to school there, and I always liked math in school, and I didn't like English or history or any of the social sciences. I was very bad at because I had difficulties reading. So for me, all those were a chore, but math was fun. And so I wanted to study math, but my mom didn't let me. Said that I would, not be able to survive just being a math teacher. And so she encouraged me to study engineering. And so I didn't know which engineering to study. So at that time, you had to fill out a paper application to go to college, and I had to actually go to the college and hand it in. And I had left the major blank, and then the person there said, no, you can't leave that blank. You have to put something there. So I was debating between the engineering. I put computer science, and so that day I made the decision to study computer science. And then I started college, and it was a very formal education, lots of math, and so and I liked math a lot. So after a year or so, I decided that I would study math anyway. And so I told my mom that I was going to study both, and that's what I did. So I did a double major in math and computer science. I had really good professors at the university, especially one who had, he had been at MIT and had studied with Marvin Minsky, who is one of the early, very famous people in AI. And when he came back to Colombia, he taught a class in AI. And so I took the class in AI, and I thought, oh, this sounds like a lot of fun. And so he was my mentor, and I did a thesis, in AI for the undergraduate. And he helped me with writing the application for graduate school. At the time you had to go and look all these things up in books. So like which universities exist in the US, I didn't even know. I mean, I had heard of MIT and Stanford, but I had never heard of CMU. And I applied to CMU because it was free. I had applied everywhere for a master's degree because I didn't even know what a PhD degree was. I never had or knew anybody who actually had a PhD in college. But CMU didn't have a master's program, so I applied to the PhD program. And they accepted me. So, it was the only of the really top schools that accepted me. So I said, well, this is cool. I'll go there. and so I ended up in Pittsburgh. The Semantic Web is a project that started, I think, about 20 years ago or more, to build knowledge into the web so that instead of having pages that are meant for human consumption, you could have pages that were meant for machines to read them and do things on your behalf. It's called semantic because the machines can understand the meaning of what's in a page, not just of the letters or the format, but what's the intention of what of the information that is on the pages and what it means. The vision was that you could have these assistants that would do things for you, like book your travel, manage your calendar, and they would be on the web as agents in different websites. So every website, instead of just having pages, would have these agents that your agent could talk to. So to book a travel, the airline would have this agent on the web, and your agent would communicate with that agent and book your travel. And so the idea is that you need all this knowledge to be represented in a way that machines can digest it and understand it. Because at the time, natural language processing was not what it is today. And so the idea that machines could read language was kind of not what you would think about. And so you wanted a sort of machine-readable representation. So machines reading text is something that existed for a very long time, maybe even earlier than the semantic web. So there were very early efforts on trying to build software that understood English. But it didn't work very well, and it was very brittle. The vocabularies were very small. The sentences had to be in proper grammar. And so it was only after many, many years of investment that machines could actually understand text well. And I think the progress that has happened in the last 3 or 5 years is just enormous, and that's what's making it possible to sort of talk to Siri or talk to Alexa the way that in your room you can just speak out to Alexa and ask something. That took many, many decades of research to get there. The idea of machines speaking to machines is that when I as a I make a request and I say book me my trip to Hawaii. Wish I could go to Hawaii again. And then it needs to go to the travel agent and ask for what flights there I can take and so on. So my agent needs to talk to the travel agent, just like a person would, but it talks to another machine. And then it may need to book me my packages, my hotel. So it goes and talks to the hotel agent. So it's not like you have the vision for semantic web was not really that you would have something like Expedia that does everything, but the hotel would have its own agent, and my agent could talk to the hotel agent and ask for deals and the kinds of rooms that I want and so on, and try to coordinate everything so that the dates line up and so on. And my agent would know that I like snorkeling or whatever, and so do all that with the agent of the snorkeling company. Karma Open Source is a project that I started with Craig Knoblock as like maybe 10 years ago now. I don't remember. And it was the PhD thesis of a student we co-advised. He came up with the name karma. The idea of karma is to be able to put data from databases and spreadsheets into the semantic web representation, so that the software that is used in the semantic web would kind of have all this information that exists in databases. And so that's we called it semantic modeling, which was to take a database table and model it using the semantics of what's called an ontology, which is a representation of what terms mean for the semantic web. So you could have what's a book, and books have authors, and authors have affiliations, and affiliations have addresses and names and so on. So this would be the idea. I joined ISI in 1988 after I finished my PhD at CMU. So I stayed as a postdoc at CMU for about 6 months after graduation, then came to ISI and joined the AI division. And I came to work on a user interfaces project that was just getting started. As I remember, at ISI, it was a big DARPA project. And then when I came to ISI, within a few months, the project was canceled by DARPA. So that was my introduction to doing work for DARPA, all the uncertainties that come with getting DARPA funding. But it was nice. There were other projects that had topics related to user interfaces, which is what I was interested at the time. And so I had a really nice early career, published a lot of the papers that are most cited in my publication record, and it was a lot of fun. When I started at ISI, I came to ISI because I wanted to work in a research lab. I did not want to teach when I started my career. So I never applied for any university job. I only applied for research labs. And when I interviewed at ISI, I was impressed. It was a really fun environment. It was much more informal than the other places that I had interviewed. When I came to ISI, it's interesting. I didn't really have a sort of research agenda that I was so very wedded to. So I had done my thesis work had been on what at the time was called model-based user interfaces, where the idea was that instead of just hacking up, programming the user interface from scratch every time, you would build a model that described the tasks and the information that this program was going to manipulate, and then there would be something that would generate an interface for a small device, for a large device. There was no web at the time, but the idea that it could be say spoken interface and so on. And so I really had high hopes for that idea, and that was the Intelligent Interfaces project at ISI was supposed to be about that. And so I was very excited about working on that. And that was sort of the project that got canceled. The idea was similar, that you would describe the tasks that users wanted to perform with the interface, and this intelligent interface would sort of customize it for you and use knowledge to sort of figure out the best way to communicate with you, in a graphical form and so on. So I thought, I did research on that for maybe 5 years, and published a lot on that. And it was something that never took off in industry. Apple had a product actually that was kind of similar to that. And then, when the web came, it actually kind of adopted some of the same ideas in a very, different way in HTML. So I felt, like, things had kind of turned out the way I thought they would, but, surprised to me in a very different way that I had never imagined, because, I had never imagined the web. I had always imagined something like a desktop computer. And then, unfortunately, the funding from DARPA for user interfaces completely dried out. And so I switched topic, and I started working more on multi-agent systems and scheduling and planning. And I worked on that for like 10 years, and had a really fun project with the US Marines that I also remember very fondly. Didn't publish much on that, but it was a super fun experience. So we were working with the Marines in the US Marines in Yuma, Arizona, where they have a Harrier jet squadrons. And so we were working with them to help them schedule their training sorties. It turns out that pilots need to fly like 100 or more than 100 different kinds of missions to be combat ready. And so you have to kind of compose a curriculum of the order in which they have to do this, and they have to refresh it and so on. And this is very complicated to do by hand. So we had a project to help them automate this. And so as part of that, we spent quite a few weeks, in Yuma, Arizona with the Marines. And that was a lot of fun too. It was also quite a life experience. The most important project I ever worked on, I think, it's clearly the DIG project that is the domain-specific inside graphs project that was funded by DARPA, where we worked on a system to help combat human trafficking. This was a project that came from DARPA. The idea came from DARPA, that you would build a system that would scrape escort ads from the web, and then analyze the escort ads to try to figure out who are the victims of sex trafficking and who are the perpetrators. This was quite an experience, because when we wrote the proposal, we did a little bit of reading about what is happening, which was very eye-opener. But when we started working on it, it really sank in, like the magnitude of the problem, and so the whole team was kind of into it. We have a chance to do something about this, and so we worked really hard. The team that worked on DIG was mostly computer scientists. So we were all, you could sort of think of a team of hackers. And the whole DARPA program had many experts that we could talk to and they sort of told us, how to learn about what is going on. And so we learned from them what are the indicators of human trafficking, what are the pieces of information that they really cared about. And so just to give you a little bit of context, when we started, we thought, okay, well, we're going to write something that's going to go and scrape, some thousands of pages from the web and, extract information and build a knowledge graph, because that's how we were thinking about it. And then, a few months into it, we realized, no, we're talking about, millions of escort ads. And so, like, you would sort of wrap your head around it, like, really millions of escort ads and, hundreds of thousands of phone numbers. And, if you think about it from the beginning to the end, the database had 100 million escort ads and about 1 million phone numbers, which gives you an idea about the magnitude of the problem. The sex trafficking industry in the U.S. is about, in the order of $20 billion a year. And so, one thing that we learned is that, many of the escorts are, it's just a business. There's no human trafficking. There's just, women, for the most part, who are driven to this job because they don't have any other job that they can do. Then there are the cases where, it was usually younger girls who are runaways from home that get captured into the human trafficking rings and are the ones that, then cannot get out. And so a lot of what we did is try to understand from the escort ads, what are the indicators of a woman who is in this situation, so that they can help her get her out of that. We were training computers to read sex ads and trying to figure out if there was if this was a trafficking victim that was being portrayed in the sex ads, and then finding all the other sex ads for that same victim, because that was the evidence that the investigators needed to make a case against a trafficker. And so what we did is, the software would read the escort ads and extract the information, the phone number, the location, the physical characteristics. We could see that the same phone number would appear in different cities, connected to other phone numbers that also moved around in some cities. And so this was an indication of trafficking rings that would move the escorts from one city to another. And of course, everything that you get from an escort ad is potentially a lie, that says, blue eyes or age. It could be the same person, and in different ads, this person is a different age or a different hair color, different, eye color. And, photos may not be the photos of the actual person, and so on. But nevertheless, we were able to glean enough information that, the investigators actually used the system to prosecute cases. It was like a shopping site. So you had, imagine, going to a shopping site like Amazon, and you type in what you want, and it gives you a sort of a bar of the different kinds of products that you can buy, TVs of this size and this size, and then it shows you the actual product. So this was the same, but for sex ads. So you would say, I'm looking for Jessica in San Diego. It would populate the bar with different Jessicas that different ages, age colors, and so on the left, and the ads, and you could click and find them. And so the investigators could then, if they had a lead, they could put the lead in here, and then focus on trying to find all the ads for one person, and they would download them and put them in their files as evidence for something. And we also had a sort of photo search capability, so you could say, here's an ad, it has a photo of this person, find me every other ad that has this photo that could be the same person, and then they would see all the locations where this photo appeared, all the phone numbers associated with it, addresses if there were addresses. One of the cases that they told us about, it was kind of a horrific story. So there was this girl that was being trafficked, and she was in a room on the sixth floor of a building, and she jumped out the window and survived. And then when they investigated, she had been already arrested, and but the problem is that the victims almost never wanted to turn against the pimps, and so but they used the system to sort of actually find all the ads that the trafficker had posted for her. There were some ads that contradicted his testimony in court that he had nothing to do with this, but they had found the ads that had been posted, and they could associate with him, and so this is the kind of thing that they did. There was also a case where they found an underage girl, and they were able to locate her in just a sort of small number of hours. In a few hours, they kind of found her, and they were able to rescue her. So we had some sort of success stories like this, and it was very eye-opener how this kind of AI technology can be used for solving what was really kind of it was an eye-opener experience for all of us that this goes on and most people don't know about it. One of the most rewarding experiences of working in this project was to see that we could use the technology that we built, AI and knowledge graphs and all the technologies that we love to solve a really important problem. That it doesn't have to be magic. We just need to work hard to apply it to the important problems, and we can make a big difference. And I think that was a sort of fun thing about being at ISI, that we could work on a project that makes a difference. And the scale of the project is the kind of thing that happens at ISI, but it would have been very difficult to pull that off just as a professor at a university. So I think those are the projects that make ISI what ISI is, and that people who work at ISI have fun working on. And we were lucky to have worked on this project. We had a project with the Smithsonian Institute to work on on building a knowledge graph of art. The Smithsonian Institute came to us to ask us to help them build a knowledge graph for art. And so, the Smithsonian had bought into the idea of linked open data. So they had heard about linked open data and how link open data connected all the data sets in the world, and they wanted to be part of that. And so we got a really small project compared to all the other projects that we have to work on building a knowledge graph of the Smithsonian American art. It was a fun experience also, a very different experience. We learned a lot about art, and we wanted to have the Smithsonian have really the first link open data for a museum in the US, and kind of put the Smithsonian as a leader on this new form of publishing data in the US. The museums keep very accurate records about their art pieces. Yeah, so and how who painted the painting, when, the biographical information about the artist, the size of the painting, the materials used, very detailed information about each artwork. And they keep this in their databases, and they are basically locked out from the public. And so there's lots of students of art and people who do research on artworks who actually want to use this information for every artwork in the world. And so the idea was that if museums published all this information that they also called like cultural heritage information in an open standard, then everybody could use it. But they had no idea how to do this. And so that's where we came in, to help them sort of expose the data that they have in their databases in a format that everybody in the world can use it for whatever they want. And so it included really the metadata of the artwork, but not the actual image. So what's the next big thing in knowledge graphs? That is an awesome question. I see knowledge graphs have become part of the vocabulary of many organizations. So, many organizations are building knowledge graphs of something that they care about. Google has a knowledge graph of every place in the world and all the information, and Amazon has a knowledge graph of all the products, and a knowledge graph of also of knowledge for Alexa, and Verizon has a knowledge graph of all the different phones and everything that any customer support person could ever want to know about phones. And so we see every industry has knowledge graphs, and but I think one of the things that we're seeing is that the knowledge graphs are kind of dumb. So they have a lot of knowledge in them, but they cannot answer simple questions about the knowledge that humans can readily answer, because they don't have any common sense knowledge. And so they are full of facts, but they don't know the basic things. So if you asked any of these assistants whether the elephant could fit in the shower, they would not be able to know that, even though it's a knowledge graph, and every kid knows that the elephant would not fit in the shower. But the knowledge graph doesn't know that. And so I think the next frontier for knowledge graphs is to somehow incorporate common sense knowledge into the knowledge graph, so that when you ask Siri or Alexa a question that requires common sense, they can also answer that, which they currently can't. One of the projects that I'm most excited about now is really about incorporating conceptual knowledge into the knowledge graphs, so that the knowledge graph has the same amount of common sense that a middle school kid has, and can answer questions about everyday objects. What can you find in the refrigerator? If I go and I want milk, where should I look for milk? And things like this, which everybody knows, but the systems don't. And so this is, we need to solve this problem to really build assistance for the house, for elderly, for people who cannot move well, and people who have any kind of handicap. We need an agent that can help them with their everyday tasks, not with answering how many people live in Mongolia. So one of the most important problems that we're working on is to teach machines to have common sense, because we need machines to be able to operate in the world with common sense much more than we need them to have infinite knowledge about the world.